Welcome. My name is Erwan Mazarico, and I am a planetary scientist at the NASA Goddard Space Flight Center. I am also a challenge author for the NASA International Space Apps 2024 Challenge. This challenge is called Exosky. The night sky has always fascinated humanity. It has helped us wonder our place in the universe, and through scientific inquiry, we have started to understand it. Telescope surveys and more recently space missions have helped map the night sky in great detail and with great accuracy. Here are three of those recent star catalogs. In 1997, the Hipparcos mission resulted in a star catalog of more than 100,000 stars. A few years later, Tycho 2 mapped more than 2.5 million of the brightest stars in the night sky. And then, very recently, the Gaia mission mapped more than 1 billion stars in our galaxy, along with their distances to the solar system. These star catalogs are now so detailed that realistic simulations can be done, such as this one here, which accurately renders the Milky Way without any telescope images. You can see in the background the Milky Way itself made of billions of stars, and in the foreground all those little dots are actually nearby stars, which are the brightest ones that we can see as humans without any aid. In the sky, our ancestors saw animals, heroes and beasts, and they connected those brightest dots to form them. Here are the official constellations from the International Astronomical Union. At the same time, in the last few decades, several thousands of planets have been discovered orbiting other stars. These are called exoplanets. Most of them have been giant planets similar to Jupiter, but with more and more advanced capabilities, smaller and smaller planets can be found that are more and more similar to the Earth. And while we don't have any knowledge of any habitable planet at this point, let alone any life beyond the Earth, one can wonder what the night sky would look like from the perspective of one of these exoplanets, what the exosky would be. And so, with this star catalog in hand, it's possible now to simulate that change in perspective to a nearby system. So for example here, what is shown is a change between a perspective from the solar system and a perspective from one of those nearby star systems. You can see the changes are pretty subtle in the background, where the Milky Way stays mostly unchanged, but all of those nearby stars, the brightest ones, those little dots all around, those are all completely changed. And so our ancestors there would have seen very different constellations, and they would have drawn a whole different series of them. So this is the heart and the fun of the Exosky challenge. To produce night skies or sky charts from an exoplanet's perspective. This can make for fun activities later on as well, such as drawing your own constellation, which will all be unique given the number of configurations that are possible. In terms of the challenge, here are some potential ideas to think about. You could develop an app or an interface to select an exoplanet and determine the resulting relative magnitudes and the position of all the stars in the sky. To help visualize those results, for example, you could produce a static image of the sky, like the sky charts or the guides here that we have on Earth and that are shown here on the right. Or more ambitiously, you could build an interactive virtual planetarium to show all those stars that have changed positions. Additional capabilities could be to trace and name the constellations to allow users to really make this exosky their own. So we hope that you take on this Exosky challenge. Check the details of the challenge on the Space App website if you're interested, and most of all, good luck!